Hello grade 8 students. For today, we will be discussing equation of a line parallel and perpendicular to a line. In today's lesson, you should be able to identify the equation of a line parallel and perpendicular to a given line. So let's have a short recall. Let's graph the following equations. So we have here 3x plus y is equals to 4 and 6x plus 2y is equals to negative 2. Again, we have three ways on how we graph linear equations. In these circumstances, we will be using slope-intercept form. So the first thing that we need to do is to convert our first expression into a slope-intercept. That would be y is equals to negative 3x plus 4. And then we will graph it on our Cartesian plane. So that is the graph of 3x plus y is equals to 4. On our second equation, we must transform it as well into slope-intercept form. It will be y is equals to negative 3x minus 2. And then we will graph. As you can see, the graph of these two equations is parallel. And then, as you observe, their slope are the same. Therefore, we can conclude that if the slopes of the linear equations are equal, then their graphs are parallel. Always remember, for us to easily find the slope of a particular equation, we must transform or convert it into slope-intercept form, which follows the form y is equals to mx plus b. Now, let's identify whether the following equations are parallel or not. So we have 4x plus y is equal to 1 and y is equal to 2 times the quantity negative 2x plus 3. So let's focus first on 4x plus y is equals to 1. When we convert this one into slope-intercept form, it will become y is equal to negative 4x plus 1. And our second equation is already in slope-intercept form, but we need to distribute positive 2 on the factors inside the parentheses. So we will have y is equals to negative 4x plus 6. As you can see, we have here same slope, which is negative 4. Therefore, the graph of this equation will be parallel. Let's have our second example. Let's say we have x minus 2y is equals to 4, and the other equation is y is equals to negative x plus 1. So the first thing that we will do is to convert these two into slope-intercept form. When we convert x minus 2y is equal to 4, it will become y is equals to x over 2 plus 4. And then, as we all know, y is equals to negative x plus 1 is already in slope-intercept form. So there's no need to convert this one. As you can see, the slope on the first equation is 1/2 and the slope on the second equation is negative 1. Therefore, they do not have the same slope, then the graph of these equations are not parallel. Now, I'll be teaching you on how to get the equation of the line parallel to a particular equation given the point. So in this given problem, what is the equation of the line passes through negative 3 and 2 and parallel to the equation y is equals to 3x minus 2. We have here our given, which is point negative 3, 2. This will serve as our x sub 1 and y sub 1 coordinate. If we want to find a line passes through this point, which is parallel to the equation of y is equals to 3x minus 2, we need to copy the slope of our first equation, and the slope is m is equal to 3. Now we have a point and a slope. Therefore, we can use the point-slope form, which is y minus y sub 1 is equals to m times x minus x sub 1. Just substitute our given to the formula. So we will have y minus 2 is equal to 3 times the quantity x minus negative 3. Let's simplify this one so that it will be clearer for us. So we will have y minus 2 is equals to 3 times the quantity x plus 3. Now we can distribute our slope to the factors inside the parentheses. So we will have y minus 2 is equal to 3x plus 9. Now that our equation is already simplified, we can transform it now into standard form. Always remember, your final answer should always be in standard form. So we will transpose 3x on the other side and negative 2 on the other side. So we will have negative 3x plus y is equal to 9 plus 2. Let's simplify it further. We will have negative 3x plus y is equal to 11. And because we have a negative leading coefficient, we will multiply both sides by negative 1. Therefore, our final equation would be 3x minus y is equal to negative 11. Therefore, the equation of the line passes through the point negative 3 and 2, and parallel to the equation y is equal to 3x minus 2 is 3x minus y is equal to negative 11. Let's have another example. What is the equation of the line passes through negative 3, 2, and parallel to the equation y is equal to 2x minus 4? Again, we have a point given which is negative 3, 2, which will serve as our x sub 1 and y sub 1 in this given problem. And then we also have here a given equation which is y is equal to 2x minus 4. Again, if we want to find the equation of the line passes through negative 3 and 2 and parallel to this equation, we need to copy the slope. The slope of this equation is positive 2. Now that we have a point and a slope, we can substitute this now to our formula, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. So just substitute it, so we will have y minus 2 is equal to 2 times the quantity x minus negative 3. Let's simplify it further to make it clearer. So we will have y minus 2 is equal to 2 times the quantity x plus 3. We can now distribute our slope to the factors inside the parentheses. So we will have y minus 2 is equal to 2x plus 9. In this form, we can now convert this one into standard form, which is ax plus by is equal to c. We will transpose 2x on the other side and negative 2 on the other side. So we will have negative 2x plus y is equal to 9 plus 2. Simplify it further, we will have negative 2x plus y is equal to 11. Again, if our leading coefficient is negative, therefore, we need to multiply both sides by negative 1. Our final equation would be 2x minus y is equal to negative 11. Therefore, the equation of the line that passes through the point negative 3 and 2, which is parallel to the equation of y is equal to 2x minus 4, is 2x minus y is equal to negative 11. Now, let's have another recall. Let's graph these following equations. So we have 4x minus 2y is equal to 2 and x plus 2y is equal to negative 4. For us to graph this one easily, we can use the slope-intercept form. So when we convert this 2, we will have y is equal to 2x plus 2 on the first equation. And when we graph it, this will be the graph of the equation. When we convert our second equation to slope-intercept form, it will be equal to y is equal to negative 1/2 x minus 4. And when we graph this one, it will look like this. As you observe our graph, it forms an intersecting line which is perpendicular to each other. When we say perpendicular lines, it bisects a line and divides the line into two congruent angles which measures 90 degrees. Again, when we say perpendicular lines, it bisects the line into two congruent angles which measures 90 degrees. As you can see here, the slope that we obtain is 2 and negative 1/2. If we will analyze it vividly, you will observe that we can form a perpendicular line if the slope of the other line is negative reciprocal of the other line. Therefore, we can conclude that if the slopes of the linear equations are negative reciprocal of one another, then their graphs are perpendicular. Let's determine whether the following lines are perpendicular or not. So we have here x minus 2y is equal to 4 and y is equal to negative x plus 1. Again, for us to easily find the slope, let's convert all the equations into slope-intercept format. When we convert x minus 2y is equals to 4, we will have y is equals to x over 2 plus 4. As we all know, y is equals to negative x plus 1 is already in slope-intercept form. As you can see, the slope on the first equation is 1/2 and the slope on the second equation is negative 1. 1/2 and negative 1 is not the negative reciprocal of one another. Therefore, the graph of these lines are not perpendicular. Let's have our second example. We have 2y plus 5 is equal to x and x plus 1/2 y is equal to 3. Again, let's convert the following equation into slope-intercept form. So on the first equation, we will have y is equals to x over 2 minus 5. And on the second equation, we will have y is equal to negative 2x plus 3. As you observe, 1/2 and negative 2 are negative reciprocal of one another. Therefore, the graph of these equations are perpendicular. Let's find an equation of the line passes through 3, 2 and perpendicular to the equation y is equals to 3x minus 2. Again, we have the given point 3, 2, which will serve as our x sub 1 and y sub 1. And then, we also have a given slope which is 3. Now, if we want to find a line or an equation of the line perpendicular to this equation, we need to get the negative reciprocal of this slope. The negative reciprocal of positive 3 is negative 1/3. Therefore, this will be our new slope for us to find the perpendicular line to the equation y is equals to 3x minus 2. So again, we will be using the point slope form, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Let's just substitute our given to the formula. So we will have y minus 2 is equals to negative 1/3 times the quantity of x minus 3. Let's distribute our slope to the factors inside the parentheses. So we will have y minus 2 is equal to negative 1/3 x plus 1. How did we come up with 1? Because negative 1/3 times negative 3 will result to positive 3 over 3 or simply 1. Now, we can convert this whole equation into standard form. We will transpose negative 1/3 on the other side and we will transpose negative 2 on the other side. So, we will have 1/3 x plus y is equal to 1 plus 2. We can simplify this further. We will have 1/3 x plus y is equal to 3. As we all know, our leading coefficient is fraction, therefore, we need to make it as a whole number. To make it as a whole number, we will multiply both sides by the LCD of it, which is positive 3. 3 times 1/3 x will be x, and 3 times y will be 3y, and 3 times 3 will be equal to 9. Therefore, The equation of the line perpendicular to y is equal to 3x minus 2 is x plus 3y is equal to 9. Let's have our last example. What is the equation of a line passes through negative 2, 3 and perpendicular to the equation y is equal to negative 1 half x minus 4. Again, we have here a given point which is negative 2, 3. This will serve as our x sub 1 and y sub 1 coordinates. We also have a given slope which is negative 1 half. For us to find the equation of the line perpendicular to it, we need to get the negative reciprocal of our given slope which is negative 1 half. The negative reciprocal of negative 1 half is positive 2. This will be the slope of the perpendicular line. Now that we have a point and a slope, we can use the point-slope form to find the equation of the line. So we will have y minus y sub 1 is equals to m times x minus x sub 1. Just distribute our given data to our formula. So we will have y minus 3 is equal to 2 times the quantity x minus negative 2. Let's simplify our signs. So we will have y minus 3 is equals to 2 times x plus 2. Now, we can distribute our 2 or our slope to the factors inside the parentheses. So we will have y minus 3 is equals to 2x plus 4. And this time, we can convert this equation into standard form. So 2x will be transferred to the other side and negative 3 will be transferred on the other side. So we will have negative 2x plus y is equals to 4 plus 3. We can simplify this further. 2x plus y is equals to 7. Because we have a negative leading coefficient, we will multiply both sides by negative 1. Therefore, our final equation would be 2x minus y is equal to negative 7. Therefore, the equation of the line passes through negative 2 and 3 and perpendicular to the equation y is equal to negative 1 half x minus 4 is 2x minus y is equal to negative 7. Now, it's your turn. Find the equation of the line given the following. Number 1. What is the equation of the line? Passes through the point positive 2, 2 and parallel to the equation y is equals to x plus 4. Second, what is the equation of a line with y-intercept 8 and perpendicular to the equation negative 6x minus y plus 5 is equal to 0. Pause the video for a while and we will reveal the answer afterwards. Here are the answers on our previous exercises. For number 1, the equation of the line is x minus y is equal to 0. For number 2, x minus 6y is equal to 48. That's all for today. Thank you very much and do not forget to access your Kuiper accounts for a short assessment. Do not hesitate to ask Sir Alex and Miss Ria for further clarification. God bless.